Today we're going to learn more about fractions, and what we're going to learn about today is that sometimes you will see fractions that are greater than one whole. So far we have learned about fractions as being part of a whole. So as an example, you could have a circle, so I could have one whole pizza, and I could cut that whole pizza into fourths, and each slice of the pizza represents 1/4 of the whole. So this is 1/4, and then this is 1/4, and you get the idea. But you can actually have fractions that are worth more than one whole. Let's look at how that's possible. So here are 4/4 that equal this one whole. So 4/4 equals one whole. 1/4, 2/4, 3/4, 4/4. Now, let's say I have two pizzas. So here's my second pizza that I'm also going to cut into fourths. So here's a fourth and another fourth and so on. Now, I have two whole pizzas here. Let's see how we could represent these two whole pizzas as a fraction if both pizzas are cut into fourths. So we have 4/4 in this pizza, and we have 4 more fourths in this pizza. Both of these equal a whole pizza. We could add the 4/4 from this pizza and the 4/4 from this pizza together. So 4/4 plus 4/4. And as you remember, when we add fractions together, as long as the denominators are the same, that doesn't change. 4 plus 4 is 8. So altogether, these two whole pizzas have 8/4. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, which is also the same as two wholes. So as you can see, fractions can actually be represented as greater than one whole. Now, let's try another example. Okay. I could have, this time, I'm going to have a candy bar. And I'm going to slice this candy bar into sixths. 1, 2, 3, 4, 5, 6. So altogether there are 6 sixths in this candy bar, which equals one whole candy bar. But what if I have another candy bar? Okay. Right? And let's say someone ate some of it, so there are only 2 pieces left. There's only 2/6 left. Someone ate the rest. So this candy bar, all 6/6 are still there, so the whole candy bar is there. And then this candy bar only has 2/6 left. We could represent this fraction in a couple different ways. We could count the sixths. We know there are 6/6 still in this candy bar. One more 6 would be 7/6, and then another 6 would be 8/6. So the 6/6 in this candy bar plus the 2/6 in this candy bar equal 8/6 in all. And that fraction represents greater than one whole. You always will be able to tell that a fraction is worth more than one whole if the value of the numerator, N is for numerator, is greater than the value of the denominator. So in this situation, since the numerator is greater than the denominator, the fraction is worth more than one whole. Because a whole is cut into 6 parts, and you have 8 of them, which means that you have to have more than a whole in order to have 8 of those parts. Now, there's another way that you could represent this fraction that is greater than 1 whole. Instead of representing it as 8/6, you could represent it another way. This is called an improper fraction when the numerator is greater than the denominator. It's improper because it's greater than 1 whole. You could also represent this as a mixed number, which means that you would keep this whole as the whole number and add the fraction on. So you could say that it is 1 whole and then 2 more sixths. 1 and 2 sixths is another way to show this. Both of these are the same thing written in a different way. So this picture represents 1 whole and then 2 sixths of a whole. This picture also represents 8 sixths. So this is a mixed number and this is an improper fraction. Now, I'm going to draw one. I want you to have out a paper and a pencil or a dry erase board and a marker. And I'm going to draw one here and I want you to try to solve it. I want you to tell me what the improper fraction would be, and I also want you to write down what the mixed number would be. And then I will share the correct answer and you can check your work. So let's try. Let's do pizzas again. This time, I'm going to slice my pizza into 8ths. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So both pizzas are sliced into 8 equal pieces. Now, I'm going to say that I still have all 8 pieces on this pizza. It has not gotten eaten at all yet. But this pizza, some pieces are missing. So some of it has gotten eaten. So 2 pieces have gotten eaten. So there are 6 slices left still on this pizza. And I'll represent it this way. So there's still 6 slices left. Those 2 are eaten. I want to know how much pizza there is here. So remember, this whole pizza is still there. This pizza has 6 slices left. Express this as an improper fraction and as a mixed number. So you're going to do it 2 different ways. The improper fraction here, and then do the mixed number. And I'm going to give you a little bit of a hint, just to get you started. The pizzas are divided into 8 equal slices. So the denominator has to be 8 because the pizzas are divided into 8ths. Each whole is divided into 8ths. So we have to figure out how many 8ths are left. And then also you're going to represent it as a mixed number. So I'll give you a hint there. Another way to show this would be to say that we know for sure that there's 1 whole still there. And in addition to that 1 whole, there are some fractional parts of a whole here. Go ahead and try to solve and figure out the improper fraction and the mixed number. And I'm going to pause for a minute because I want you to try to work through it. And if you need more time before I share the answer, you can pause the video yourself. Okay, remember to pause if you're not ready to continue yet. I want you to figure this out first on your own. So let's talk about it. I'm going to count how many 8ths I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have 14 8ths. That's how many That's what fraction of pizza I have left. That's the improper fraction. Each pizza is divided into 8 equal slices. And originally, I had 16 slices. Because if these 2 slices were still there, I would have had 8 here and 8 here, and that would have been 16. But someone ate 2 of them, so there are only 14 slices left. So there are 14 eighths left. And another way to represent that would be to say that I have 1 whole pizza still, and then I have 1, 2, 3, 4, 5, 6 eighths of my other pizza left. So I have 14 eighths. Another way to say that is I have 1 whole plus 6 eighths more. This is the mixed number. This is the improper fraction. Okay. Now, let's do a few more. I want you to get out on your paper. I want you to letter your paper A through F. So I want you to put A, B, C, D, E, and F on your paper. And we're going to go through these problems together. Okay, so I want you to look at problem A. And I want you to solve these along with me because that's the only way that you're going to get practice with this and feel comfortable with it. So let's look here. We have 3 whole squares. You could imagine that they are anything. You could have a square candy bar, it could be a square pan of brownies, anything you want it to be. Okay? These squares are divided into fourths. So if you look, each square is divided into 4 equal parts. This is a fourth, here's a fourth, another fourth, and another fourth. Okay? They're divided into 4 equal parts. All of them are divided into 4 equal parts. I can express this 2 ways, as a mixed number and as an improper fraction. Let's first express it as an improper fraction. So, let's think first. Each square is divided into 4 equal pieces. So our denominator is 4 because these squares are divided into fourths. Now, we're going to figure out how many of them are shaded. That's how many are left. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of the fourths are shaded. So this fraction would be 9 fourths. Now, another way to represent that would be to represent it as a mixed number. So, let's see what the mixed number would be. This is 1 whole, and this is another whole. That is 2 wholes. In addition to those 2 wholes, I have 1 more piece out of a fraction that's divided into 4 pieces. So I have 2 wholes and then 1/4 of a whole. 2 and 1/4 is the same as 9 fourths. Okay? All right, let's look at problem B together. So we have pies here. What are the pies divided into? How many equal parts? You can say it out loud even though no one's there for you to hear it. Okay, so if you said that these pies are divided into thirds or 3 equal parts, you are correct. They are each divided into 3 equal parts. So our denominator will have a 3. We have to figure out how many thirds there are. And all we do is count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 thirds are shaded in. That's the fraction of the pies that I have. I have 10 thirds of a pie. Now, I'm going to represent that as a mixed number. First, let's figure out how many whole pies I have. 1, 2, 3. I have 3 whole pies. Plus, in addition to those 3 whole pies, I also have 1/3 of another pie. So I have 3 and 1/3 pies. Here's my improper fraction. Here is my mixed number. Okay? Now, let's look at letter C. I want you to solve C on your own. write the improper fraction and the mixed number. I'm going to pause, and then we're going to review it. Okay, so let's review. Each star is broken up into 1, 2, 3, 4, 5 equal pieces. So 5 equal parts. So these stars are broken up into fifths. Let's see how many fifths we have. Well, we know there's 5 fifths here. And then there's 5 more fifths, so that's 10. 11, 12, 13, 14, 15. 16, 17, 18, 19, 20, 21, 22, 23. We have 23 fifths. Hopefully you represented that also as a mixed number. Let's take a look. Let's see how many holes we have. 1, 2, 3, 4. 4 holes. And then I have 1, 2, 3, 3 fifths of another hole. So 4 and 3 fifths I have. Okay. Now, I want you to solve D, E, and F on your own. Please pause the video because I'm not going to pause for very long. I want you to pause it. I want you to work through them all. Unpause the video after you have completed them, and you will be able to see the answers that I have written out so that you can check your work. Okay, take a look at what you got for letters D, E, and F. Both the improper fractions and the mixed numbers. If your answers are different from mine, check where you may have made a mistake. Okay, if you need to pause in order to keep checking your work, feel free to do that before we move on. I want you to feel confident with this before you move to the next activity. Okay, I want to take a look at what these fractions that are improper or greater than 1 might look like on a number line. So let's take a look here at this number line. You don't have to draw a number line on your paper. You can just have a blank piece of paper out and you can write down the fraction that you think is going to fit in this box. So, as you can see, I have a number line broken up into halves. So, if we stopped here, this is one whole. Okay, this is one whole. So, right in the middle is half of that whole. And another way to represent that one whole would be to say that it is 2 halves, because 2 halves make a whole. But what happens if you go further than that and you go past one whole or 2 halves? What would your fraction be here? Let's think about that. I have 1 half. I have 2 halves. So wouldn't it make sense to say that now here I have 3 halves? Because I already have my whole broken in half. And now I have another part of a whole broken in half. And if I were to continue on, I'm just going to show you. If I were to continue on here and draw a line here, this would be 4 halves. Okay? And that would also be the same as 2 wholes. 0, I have 1 half, and then that makes a whole, and then I have 3 halves, And then I have another whole, so I have 2 wholes now. Okay. Now, let's take a look at another example. This time, I want you to write on your paper or on your board the fraction that you think would come here next before I share what the answer is. Remember, we still have broken up our number line into the same number of pieces. So this whole in this situation is broken up into thirds. So if we have another third, the denominator is still going to be 3 because this is broken up into thirds. This space represents 1/3. This space represents 2/3. And this space represents 3/3, which is the same as a whole. This space represents another third. So how many thirds would that be? If you said 4/3, you are correct. I could express that as a mixed number. So we know that at this point we have 1 whole. In addition to that 1 whole, I have 1 more third. So instead of saying 4/3, I could refer to this as 1 whole plus 1 more third. And that makes 1 1/3. All right. Now, there's one more thing that I want to go over before we stop. And that is that there is another way to represent, I'm going to use my dry erase board, whole numbers as fractions. And you may see this done this way as well. So I want you to think about this for a second. If I have 3 cookies sitting on the table, okay? No one has eaten any of the cookies. They are still there. Beautiful. They have chocolate chips in them. They look great, okay? I could say that I have 3 whole cookies. Because it's true, that's what I have. 1, 2, 3 cookies. Now, if those cookies are not broken up into pieces, because you don't usually break cookies, you usually keep them as a whole cookie. So if you did not cut them at all, and you keep them as whole cookies, you could still express this as a fraction. So you could still say that these cookies are broken into 1 piece because there's only 1 piece in each cookie. They're not cut into any more than 1 piece. So they're broken into 1 piece, and there are 3 of them. So 3/1 is another way to represent this fraction. 3 wholes is the same as 3/1 because they are broken into 1 piece total. They're not cut into any more pieces than that, and there are 3 of them in all. So 3 in all divided into 1 equal piece. 3/1. It's kind of weird, but you will see this sometimes, and I don't want you to be confused. Whenever you see a whole number in the numerator and the number on the denominator is a 1, it's just that whole number. So, for example, I could add another 2 cookies onto this. They're still whole cookies. I have not divided them into any more pieces than that. So, they're still divided into 1 equal piece, each one, but there are 5 of them now. So it's 5/1, and that's the same as 5 whole cookies. 5/1 equals 5. This would never, ever, ever change. So if you were to see something like this, if you were to see 12/1, that is the same as 12 wholes. If you see 200/1, that's the same as just 200 wholes. Okay? Whenever you see a fraction where you have a number over 1, it's just that number. And that's something that I want you to make sure you understand as well. Okay? All right. So be sure to fill out the Google form today to solve the problems involving numbers that are greater than 1 as fractions. And good luck. Bye.